We're on problem 173. The probability is 1/2 that a certain coin will turn up heads on any given toss. Fair enough. If the coin is to be tossed 3 times, what is the probability that on at least one of the tosses the coin will turn up tails? So probability at least 1 tails. And that might seem really hard for you. How do I know which tails it is and all of that? But let's think about the opposite circumstance. This is equivalent to saying, what is the probability that I don't get all heads? Right? These are equivalent things. At least 1 tails means that I don't get all heads. And what is the probability that I don't get all heads? Well, that's 1 minus the probability that I get all heads. Right? And figuring out the probability that you get all heads isn't that hard, because you have a half probability of heads on the first time times a half probability because you have to get a heads on the second time times a half probability because you have to get a heads on the third time, and that's equal to 1/8. So 1 minus 1/8 is equal to 8/8 minus 1/8, which is equal to 7/8. So that is choice D. And a lot of these probability questions, you have to get at least one of something. If you think of it that way, it's very hard, and you'll have to start thinking of combinatorics and binomial coefficients and all of that. But if you just think of the opposite problem, what would have to be true? That I don't get all heads. Well, what's the probability that I do get all heads? And then that's a much easier thing to solve for. And then you just take that from 1, and you get the probability that it doesn't happen. Next question. 174. Of the final grades received by the students in a certain math course, 1/5 are A's, 1/4 are B's, 1/2 are C's, and the remaining 10 grades are D's. What's the number of the students in the course? So if we know what fraction 10 is, then we know the number of students in the course. So essentially, let's see, what are these fractions add up to? So let's find a common denominator. Looks like the common denominator between 4, 5, and 2 is 20. So 1/5 I get A's, so that's 4 20s, plus 1/4, so that's 5 20s, plus 1/2, that's 10 20s. So the A, B's, and C's are equal to, what is this? 4 plus 5 is 9, plus 10 is equal to 19 20ths of the class. And they're saying that the remaining 10 grades are D's. So there are no F's in this class. So the remaining grades, that's 1/20th of the class. So that's equal to 1/20th, right? Because if the A's, B's, and C's are 19 20ths and all the other grades are D's, then all the other grades are going to be 1/20th of the class, because that's what's left over. So if I say 1/20th of the class is equal to 10, multiply both sides by 20, and you get the class is equal to 200 students. And that's choice D. Next question, 175. 175. As x increases from 165 to 166, so as x goes from 165 to 166, which of the following must increase? Interesting. So 1, 2x minus 5. Well, sure. As I go from 2 times 165 to 2 times 166, this is obviously going to increase, and this is going to stay the same. So this is going to increase 2, and you can substitute the numbers in there if you don't believe me, but I think that should make some intuition. Statement 2, 1 minus 1 over x. So 1 over 165 is greater than 1 over 166, right? This is a larger fraction than that is. 1 over a million is much smaller than 1 over 2. So 1 over 65 is greater than 1 over 66. So you might say, oh, as I go from 1/65 to 166, this term right here gets smaller, right? That term does get smaller. But we're subtracting that term. So if we're subtracting a term that's getting smaller, the whole value is actually going to get larger. We're subtracting a smaller number as we go to 166. 1 minus 1 over 166 is a larger number than 1 minus 1 over 165. So this also gets larger. Statement 3. 1 over x squared minus x. So the question is, what happens to x squared minus x as we go from 165 to 166? And if you think about it, we are well beyond any type of, x squared, any kind of vertex in this. I mean, if you know a little bit of calculus, you could figure out the vertex really fast. So we're this is going to be some type of a parabola. This x squared minus x is going to look something like this, right? And its vertex is actually, let's see, 2x minus 1 is equal to 0. Its vertex is that x is equal to 1/2. It's a very small number. So we're in the point of this curve that's increasing upwards, right? So when we go from 165 to 166, this right here is definitely increasing. This denominator is definitely going to increase from 165 to 166. You might say, oh, well, we're going to be subtracting a larger number, but that's more than offset by squaring the larger number. So this denominator is going to increase, but if the denominator is increasing, then the whole fraction, which is the inverse of the denominator, that's going to decrease. So this one is not increasing. So 1 and 2 only. So that's C. Next question, 176. And I'll do it in a different color. 176. A rectangular box is 10 inches wide, 10 inches long, and 5 inches high. So it's 10 inches, and then 5 high. Fair enough. That's the box. What is the greatest possible distance in inches between any 2 points on the box? So this is a bit of an old trick. So the longest distance in this box is kind of three-dimensional diagonal. So a normal diagonal goes along one surface, but if you go from this point back here, and I'll do that in a different color, to this point over here, that's the longest dimension in the box. And if you know how to figure out distance in 3 dimensions, then that's all you really need to know how to do. It's going to be the square root of 10 squared plus 10 squared plus 5 squared. And so that's the fast way to do it. And I'll show you the logic of it in a second. So 10 squared plus 10 squared plus 5 squared. If we had a 4th dimension, which is hard to visualize, we would add that distance squared and take the square root of everything. And so this is equal to the square root of what? 100, 225, 225, which is equal to 15. And that's choice A. But let me give you the logic. So if I'm taking the distance from this point to this point, how do we figure that out? Well, let's see. The easiest way to think about it is, can we figure out this distance right here? So this is going along the top of the box. Let me do that in the magenta. This diagonal that's along the top of the box. Well, sure, if we look at the box straight down, what I just drew, if this is 10 and 10, what I just drew goes like that. Right? And it's going along the top of the box. So this is going to be the square root of 100 squared, the square root of 10 squared plus the square root of 10 squared. So this, just Pythagorean theorem, this distance right here is the square root of 200. Right? I just used the Pythagorean theorem. I just said this is 10, this is 10, so this has to be the square root of 200. Now we have to do a little bit of visualization. To figure out that green line that's the longest diagonal in this box, think about it this way. We still have a right triangle, although maybe it's a little harder to visualize. Well, maybe it isn't. So the right triangle looks like this. It looks like this, where this side is the square root of 200. That's this up here. This side right here is 5. They tell us that. So this side right here is 5. And then the diagonal that we're trying to solve for is in green. That's the longest diagonal. And if we did it, remember, this line is the same thing if you view from the top as this line. It's just you can't see what's below it. So here we just use the Pythagorean theorem. So we could say c squared, let's call this c, is equal to 25 plus this squared plus 200. And then you get to the same answer that we just got to. So c is equal to the square root of 225, which is equal to 15. And that was, what problem was I on? That was choice A, if I haven't already said it. Anyway, see you in the next video.